Welcome, everyone, and thank you for attending my session. My name is Pinto, and in this session, I'd like to talk a little bit on NQL, our next generation rich query language for Couchbase. So what is NQL? So this is going to be the brief agenda of my talk today. We'll start with kind of describing NQL, and NQL is a rich query language for Couchbase. But in addition to that, we'll like to define things like what is rich data, how would you compare a relational data model and the NQL data model, our mission for the NQL query language, the resources that you can use to kind of learn more about NQL and as well as try NQL out. And finally, we'll leave some time for Q&A and a demo at the end. So the real world, what is the real world? So the real world is rich and complex. So you see here you see a shopper who's going through sections in a supermarket and different other kind of pictures from the real world. The data generated in this real world is also rich and complex. So when you have all this rich data, you need a different kind of database, a different kind of backend to kind of store as well as process this kind of information. And one such NoSQL database that you can use is Couchbase. So Couchbase provides you with different characteristics, but the most important characteristic, the ability to store and process flexible data and allow you to build applications in a much more agile fashion. So Couchbase offers a range of data management solutions. So you can do everything, use Couchbase for things like a high availability cache, a key value store, a document database, as well as Couchbase Lite on your cell phone device that can be used to then sync your data, Couchbase Lite data with Couchbase in the cloud. So what is the basic data model? So traditionally, data is modeled in the form of rows and columns. So what you can see on the left is entities like the people and the city lived, and then the associations between these two so-called tables. And this data model is two-dimensional, it is rigid, it's flat. It is not a natural way of capturing rich data that we talked about, rich data that you get in the world. So with the emergence of big data and richer interactive apps, a new data model has emerged. And this data model is the rich data model. So what you can see in this example here is a rich data model representation of a person, where the person, she has a name, date of birth, the credit card she uses, the social connections she has, and the kind of products she purchases. There's also information about the product, like what exactly is the product she buys, what are some of the details, other details of the product, and as well as some of the social networks the person belongs to. So how would we compare these two data models that we just saw, the basic data model and the rich data model? So in the basic data model, real-world objects are decomposed into rows and columns. Again, as I described before, this is two-dimensional, this is rigid, this is flat. And to recover a data from using the basic data model, you need to combine these multiple so-called rectangles, which are rigid and flat and two-dimensional, to kind of recover the entire the object. And this kind of recovery process is expensive because you do things like joins to kind of recover the original object. In the rich data model, however, rich world objects are represented as triangles. Right? So they don't only have a length and a width, they also have a depth. And and to recover these, the complete object is stored in these triangles. So if you want to, the object is represented as is, and you can recover these objects in one shot. But they do have associations with other objects. So here what you can see is two triangles, and they are complete objects, and they're kind of represented, they have links with each other. So in summary, what the rich data model gives you is it introduces a new technology. It naturally models real-world data. It matches your application data model, as well as embraces flexibility and change. So what is nickel? So again, going back to us, the question that we started with, what exactly is nickel and what does it bring? So nickel brings together three foundations. The foundations of SQL, a language which you all are familiar with, JSON, the ability to store data in Couchbase in the JSON document format and use a query language like nickel to operate on these JSON documents. And the third thing is N1NF, or also called non-first normal form, which is a superset of SQL relational normal form. So the combination of these three things, the expressive power of SQL, the rich data, the JSON-rich data on which this query language runs, as well as the non-first normal form, which makes it not only SQL, but more than the SQL, is what nickel is. So what does nickel achieve at the end? So nickel achieves the ability for developers. It gives them freedom and flexibility because now you have developers can use a language, a SQL-like language, which you're already familiar with, and also operate on rich data. It gives you power for big data applications because now you have loads of information that is stored in a database like Couchbase, and the ability to index and query this data at scale, as well as use some of the indexing capabilities that nickel provides to then kind of power your querying capabilities of Couchbase. And finally, value to customers. The new technology, since we moved from traditional databases now to this world of NoSQL databases, even the querying technology has evolved and providing you with this new query language that now can work on NoSQL databases. So let me walk you briefly into some of the features that nickel provides, from a read perspective, from a write perspective, and so forth. So let's start with the read perspective. So what you see on the slide is a bunch of clauses that nickel supports. And what you would notice is, hey, this looks exactly like SQL. And yes, it is. I mean, as I said, nickel is basically SQL and more. So what you can see is this is a simple example of where you would have a simple select statement, where you would have you do a distinct from, a join, also group by, limit, offset, union, as well as explain if you want to explain your query plan, a nickel query plan. Then in terms of writes, you have things like create index. You would have drop index, where you would create these secondary indexes in Couchbase using the create index statement, as well as drop index statement based on when you want to drop an index. As well as you then have DML operations, like you have insert and update and delete and merge, right? So all these are, some of them are already available with the DP3 version of nickel. Some of them are yet to come as we continue working on nickel and integrate nickel with Couchbase. Then we have expressions. So we have expressions which are just like SQL. You have literals, operators, scalar functions, aggregate functions, subqueries. And so that's kind of what we all know from the SQL world. So what's the extra stuff? What's the stuff that is more than SQL? So the extra stuff that is more than SQL are the next few slides that I'm going to talk about. The first one is nesting. So given that we have rich data, now the data is represented in the form of JSON documents. This data also, you would have, for example, arrays and lists and collections within this JSON document. And so what nickel will provide is nickel provides these expressions that you can use to then operate on rich data. So things like nest and unnest, things like collection aggregation, traversals, where you can have like 2 or 3 level depth of particular entities, and you can use nickel to then traverse these. You would also do things like arrays and update of these arrays. So that's a little bit on nesting. The next one is about heterogeneity. So in this one, you would have things like where you would have schema inference, you would have attribute removal, implicit types, and so forth. So these are things that which gives you heterogeneity in your different data that you represent within JSON. And finally, the features for distributed data. So the distributed data features like where you would have key value access, where you would still be able to use Couchbase's key value access along with nickel to query your data, as well as query document metadata. So if you have document metadata, you can also access document metadata with nickel, as well as the key value kind of access patterns, which you'll be able to do and see in some examples that I will show of nickel. And finally, you would have limit and the ability to use limit on update and delete statements. So that's kind of a summary of nickel. Some of the resources where you can find more about nickel would be as follows. So you would have, you could go to query.couchbase.com. This is a single landing page where you can get all the information you need about nickel. And today we're going to look at some of the example queries on this page. And there is also a Twitter handle that if you want to follow us and understand some of the updates we are doing with the nickel language, so feel free to follow that Twitter handle. So now I'd like to switch into a demo on some of the different stuff we have done with nickel and walk through some of the queries. So what you can see on the screen here is, if you go to query.couchbase.com, you would land to this page. And this page gives you, again, it's a one-stop shop for nickel, gives you things like the cheat sheet. You can also stop by a booth later on to grab this cheat sheet if you want a hard copy of it. There is also the Couchbase language tutorial, which is what I'm going to show you a few sample queries today. So this is a live tutorial. You don't have to download anything. It runs on the website. You can play with nickel on the website and see how it works. So this is exactly what the live tutorial is about. And what I'm going to do today is maybe walk you through some of the queries from some of our use cases that we have within our tutorial. So the first use case is an e-commerce use case. So some of the queries which are very common in e-commerce are kind of captured here. So for example, let's say you want to count what this query does. It's a simple select query. And it counts, so we have a product bucket in Couchbase, which stores a bunch of JSON documents. And we want to get, we want to count these products which are represented in JSON. So if I run this query, you will see here that we have 900 products in this database. Right? So let's look at some other interesting queries. So I'm going to go back to the index, and I'm going to take a look at other interesting queries. So let's look at browsing and searching for a product. So this is an example query where you have a product, you have the product ID, the name of the product, and you want to search for product names where you have a name, it has a substring with the word cup. Right? So again, when you run this query, what you'll see is the output is also JSON. Remember, so what we saw from the last slide is the input was JSON. The output is also JSON. So what you can see here is the result set where the product names would have the word cup. So let's look at some more queries. Maybe the most popular products in the category. So this is a fairly advanced query. So what you do here is you're going to do a select, you're going to do a count, you're going to do some mathematical rounding functions. Then you're going to, so basically there are a couple of things going on here. So you have the category, the product which is definitely in the product bucket. But there are other buckets which are storing reviews and other buckets which are storing, so there's review bucket which is joined with the product bucket as you see here. So this is an example where you have the product and you're kind of joining it with the reviews to get reviews for those products, and then kind of using those reviews or the rating of the reviews to kind of do some, to kind of project on those. So you'll also see some advanced clauses here like unnest, where product categories may be an array and where you want to basically unnest that particular array, so you can kind of flatten it. So things like unnest clauses are used there, and as well as now we have a where clause where the category is set to appliances. And finally, group by. So if you do that and we run this, so this may take a few minutes. Okay, here we have it fast. So you have this result set that comes up. You have the average rating of the queries. Again, notice that we had this descending limit 3. So what it did is it limited the data set to 3 records. And what it did is it also sorted, it ordered by average rating. So you see the average rating 4.5 and then 4 and then 3.4. So this is an example query to find the most popular products in a particular category, for example. Let's look at some more queries, right? So we'll look at browsing and sorting results. So this is a familiar operation when you go to, again, e-commerce websites. You have to sort, and then you browse, and then you also sort by, different attributes. So what we have here is, again, the product. You have the sum of the product. You have from. join, group by, order by, very similar to the last query, right? And so when we run this one, this may take a, so again, it depends on how many documents are in the different buckets when you're doing the join. So you have the result set here, and again, very similar like the last query. You get, again, descending by the units sold, and here we have a limit of 10, so we have many more output rows or so in the result set. Let's look at some other queries which might be interesting. So purchase order. So this is interesting. So the customer, he shops around, he looks, he browses, he searches, he finds a product he's interesting. Finally, he makes a purchase. And when the purchase is done, you create a purchase order. So when the purchase order is created, again, it's a query that has multiple joins. It takes products. It takes the purchase bucket. It's joining on a particular key. In this case, it's creating, for the purchase with a key with ID purchase 0. Unnest, again, the purchase line items, and then it's kind of joining that with product as well as joining, again, that with customers. So if you do that and run this query, what you'll see is an example of a sample purchase order that was created by combining data, which is represented again as rich JSON documents in these three different buckets. So you're able to create a purchase order just by using a simple statement, nickel statement like this. And if we continue a few more queries, let's pick up a reporting query. So let's say we want to, marketing wants to then go and be able to have a marketing campaign which to target particular regions. So they want to know what is the customer count from each of these regions. So if you run this query like this, again, you can get the different kind of states and the counts for each of these states. So then you can marketing can go and use this query to kind of target campaigns for these states. And let's take a look at maybe one more query, the month-over-month sales. So this is interesting. So once you have purchases, you want to look over the month. Sales team may want to look over the month-over-month sales, and they may have a little bit more complicated query like this. So they have a bunch of they have again using a substring function, round, sum. They're again doing from. Again, they're joining this purchases with a product. Again, doing some level of group by, and then finally ordering by month. So if you run this query. So finally, you have the result set here. So the result set talks about the different months and the revenue in $1 million per month. So hopefully that gives you a good understanding of some of the different things that you can do with Nickel, what Nickel provides as a language, some of the different ways in which you can use Nickel to query your rich data. One more example I'd like to show, maybe two more queries. So as you explore the tutorial for yourself, you'll be able to play with these other queries as well. This is another use case where Nickel was used for social gaming. So in social gaming, you have user profiles, you have users doing actions on objects, finally you have scores, right? So let's look at a simple query where you want to generate a scoreboard. So this is like, think about it, where you have an online game and you want to generate a scoreboard for your players. And so in this query, what you have is a bunch of case statements, so which is also what Nickel supports. And you can then query from a particular bucket and then on a particular key, and then doing a bunch of unnest operation as well as group by. So when you run this query, you will be able to see the player and the opponent of the player and the wins and the losses for each of this. So this is a simple example of a scoreboard that was generated as a result of using Nickel. And one more query here could be listing friends. So it's a social game. You may have you're playing the game. You may have friends also represented as other player objects. Again in JSON. And if you want to run this query, for example, what this does is it selects, it joins, it takes this particular key from this bucket and it joins it with to explore friends for this particular key with the other. It just basically calls the friends to kind of understand what the array is for that particular document. So that's why we use the dot operator here to kind of explore a particular attribute within the JSON document. So in this case, jungleville.friends would be an attribute within the document. So if you run this, what you'll be able to see here is the friends for this particular key, again, scanning across the different JSON documents. So that's pretty much it. So we'll switch back to the slides, and if there are any questions from the audience, I'll be happy to take it now. Again, just before I go there, again, it's query.couchbase.com. Whatever you saw today, you can explore it, play with it live, and give us your feedback. Thank you. So we'll leave maybe 5 or so minutes for questions. So anyone with questions? That's a good question. So the question was, do you have bulk inserts in Nickel? So definitely it's not in DP3 release that you can see today on our website, but it's definitely is something that we are thinking about from a long-term perspective. It's definitely on our roadmap to do ability to do bulk inserts. One thing I would like to mention with Couchbase, today there are different ways of querying Couchbase. So you can query Couchbase in a key value fashion, which means you can give it a key and then get the document back, a single document back. And since you were talking about bulk inserts, we also support multi-set and multi-get operations. So you could give Couchbase a bunch of different key IDs, and we can set those in a bulk fashion. And again, given that that is one way of querying, Nickel would be another way of querying your rich data. That's something that we would also consider adding in. Yeah. Yes. So if I understood the question right, you want to understand how Nickel uses joins? Okay, cool. Yeah, so the question was, initially I said that SQL would use joins, and you use joins for composing back an object. So if you want to compose an object back, you would, given that you would traditionally denormalize your data and then use joins to kind of recover back your object. And with the Nickel, I did show some examples of joins. So why is that better? Did I understand the question right? Okay. So traditionally, again, we all know how we would represent our data in a relational database. That's pretty much by denormalizing the data, being ability to do multiple joins across these tables. And we all know that joins are really expensive. With Nickel, yes, we do support joins. But what we can do is the ability, what you also have within Nickel or within JSON is this ability to have your rich data within a single document. And we have seen some customers just model their data, model their rich data within a single document. Yes, there may be some cases where you want to, let's say your data is getting updated a lot and you want to take this subset of the data and not just put it within a single JSON document, but just move it into a separate JSON document. And that's where you may need to do joins. But in reality, you can just query it at one shot. And the reason what I showed here is, yes, it is SQL-like in the sense that you can operate on using a simple select statement, but then you don't really need to do joins. You can do things, but things like nest and unnest are really powerful because it helps you operate within a single JSON document and get information which can be fairly deeply nested, which you cannot do with SQL. Any other questions? Yes, sure. So the question is, if you have a bucket where you don't have separate buckets, you have a single bucket and you have a type identifier for your different types of documents. Is that correct? So how would you write a nickel statement? So your nickel statement can be written in that case on that bucket, and you can then filter, because nickel also supports filtering. So you can do a where clause where you would filter on that particular type. So you could apply a filter for that particular type if the nickel query has to just go against that particular type. And you can also combine things, right? We saw there are operators like AND. So you can say where type is equal to, say customer and some other attribute. So you can basically combine these different types. So you basically reduce. It helps you get a subset of your data and then operate on that subset of the data, which still may exist within the a larger bucket. Any other questions? Okay, cool. So thank you very much. And if you happen to want to grab one of those nickel data sheets, please stop by our booth, and we'll be giving them out there. Yeah, thank you.